talk to your neighbors, please. All right, section 2.4, linear equations, and we're in two variables. Do you guys recognize this notation? Have we ever seen that? I don't remember teaching it. Doesn't mean you haven't seen it, though. You know what M is? What's M? Slope. So that is delta, and what it means is change in. The change in. So we've got the change in y over the change in x. You guys recognize that as the slope formula, y2 minus y1 over x2 minus x1. You'll see this more and more, especially as you get into calculus. So it's just change in. Here's some stuff to remember. The slope of a horizontal line is 0. The slope of a vertical line is undefined. I don't know why that's all in there twice, but it is. Average rate of change is a fancy name for slope. Okay, so when you ask you for the average rate of change, even if it's on a curve, can I find the average rate of change? We'll make that point really big. Can I find the average rate of change between those 2 points? For sure. Okay, so it's just asking you to find the slope between any 2 points. All right, there's a whole bunch of terminology. Graph the line. We are in slope-intercept form, which is our best friend, because we know the B is the y-intercept, and we know that M is our slope. And when we graph our slope, we know it is rise over run. All right, so I'm going to start graphing at my y-intercept at 4, 1, 2, 3, 4. Do you guys like to go up and left or down and right? I know, everybody's different, so that's why I asked. I kind of like to hear. It's like, no, it's this way. No, it's this way. So rise over 1, 2, 3. There's that one if you're in up and left. There's that one if you're down and right. Alex would make it easy, right? You just use their tool. I'm going to cheat and use my ruler. Any questions on that one? We should be pros at that. Pros. Yeah, pros. Positive, negative, undefined, or 0? Negative, 0, undefined. Oh, another negative. So this is a positive, right? Flying through. I always kind of smile and snicker to myself, never allowed to my students, but when they come and they get these points and say, okay, this is 3, 4, and this one is -2, 1, and then they do slope formula. Is that a great way to get the answer? Absolutely, but was that a lot of work?
Yeah.
So much. So I was like, oh, good job, you did it. And I don't want to, burst their bubble and say, or can we just do a slope triangle? For sure. So even if we have a curve on your homework, you guys, you can do the slope triangle, all right? It's just our rise over run. You do have to remember to put in if it's positive or negative. So this one went up 3 and it ran 5?
Yeah.
So 3/5? Okay. I think we'll just do one of these. Oh no, they're vertical and horizontal lines. I'm not going to solve those for you, but what I am going to do is this. If we have 0 over any number, what does it equal? 0. If we have x over 0, What is it? Undefined. If you guys remember the difference between those, you'll be able to do both of those. Graphing an equation, it wants us, okay, if it hadn't asked for the slope and the y-intercept, I probably would have done the cover-up method here and just found my intercepts, my x and y intercept, and connected the dots. But because it asks for the slope and the y-intercept, this form is friendliest. So yes, Spencer, I would solve for y. All right, so I'm going to have a negative 6y equals negative 3x minus 6. Divide everything by negative 6. 1/2 x plus 1. So my slope is half. My y-intercept is 1. Up 1 over 2. I know I'm cruising through these, so I'll stop right now and ask if there are any questions. All right, I'll pause and let you catch up for a second. I see some mad, crazy note-taking.
All we do is add the y to that equation and then solve it down.
So we move the x to the other side and divide it by negative 6. Yeah, well, and I jumped clear across the page, so. Yep, move the x to the other side and divide by the constant in front of y. Okay to turn the page? Okay. Now this one you've forgotten how to do, some of you, so I'll remind you. Average rate of change is a fancy name for what? Okay, so we're finding the slope. We know that's not linear, but it's asking in between when the x value is 1 and when the x value is negative 2, or the other order. So this is what I like to do. I make a table. I guess I should have called that f of x, since we have f of x up here. F of x. I am going to substitute in negative 2 and 1 into the equation they've given me. Chances are they're going to make it ugly. So if I substitute in negative 2, oops, I forgot my cube. Type it into your calculator or remember your order of operations. Negative 24, 4, minus 8, minus 3. Did I do that right? Negative 32, negative 35. And then I'm going to substitute in 1. 3, 1 cubed, minus 2, 1 squared, minus 3, 3, minus 2, minus 3. That one was nicer. Now that we've done all of that hard work, we have 2 points that we can find the slope in between. And you're just going to use our slope formula. Change in y over the change in x. So negative 2 minus a negative 35 over 1 minus a negative 2. 33 over 3, which is actually kind of pretty for a Math 1050 answer. Now, my Math 3 honors class last week, we were doing similar problems, and they kept getting them wrong because they do their change in y in one direction, and they were doing their change in x in the opposite direction. Just remember, we need to move in, from the same point to the same point, y's and x's.
Do you always just do -2 and 1?
You do whatever is given in the problem. Yep, so whatever is, good question. Whatever is given in the problem. Okay. Point slope formula. I am going to choose to rewrite it because it branches 2 lines there. My brain wants to see it all in one place. This will be on your formula sheet. I see some of you have it on your desk when you're doing your homework. It's a good idea, just because then you get used to where it is and you don't have to dig for it on your test when it comes. Whenever they give me a point and a slope, and I'm kind of obnoxious when I teach this in my Math 2 and Math 3 classes, I keep saying, I have a point and I have a slope. I have a point and I have a slope. I have a point and a slope. Hopefully to remind you that we are talking about, yeah, we're going to use the point slope formula. So this is our x1, our y1. Here's our m. So y minus 7 equals -1/2 x minus 10. Now if it asks for the equation of a line, you're done there. That is the equation of a line, but what does it say? Yeah, so if it wants it in slope intercept, we are going to have to solve for y. So we'll distribute. And then to get that y alone, add 7?
Yep.
Is this a whirlwind linear equation review? Excuse me, my goodness. Oh, we're close, but we're not there yet. Sorry, I'm moving it too fast. Remind me about parallel and perpendicular slopes. Parallel, the m is the same.
Perpendicular slope is flipped
M, opposite reciprocals. If you don't like math speak, flip the fraction upside down and change the sign, right? Flip the fraction upside down and change the sign. Half of the battle on these problems will be just making sure you're understanding what they ask. Consider this line. What is the slope of a line parallel? Can I find the slope of this line in this form? Absolutely, the y's alone. So the slope of this line is 3/4. So parallel slope would be the same, 3/4. Perpendicular, what did we say we do to that one? Change its sign and flip the fraction. Opposite reciprocal. Last page. The equations of 3 lines are given below. For each pair of lines, determine whether they are parallel, perpendicular, or neither. I don't know how you would answer that. So I need to know the slope of each of them, right? That one I can find the slope. How do I find the slope of this one? Divide everything by 3, get the y alone. So there's its slope. And then Lydia, to follow up with your question on this one to get the y alone, move the x and then divide. So 6y equals -4x minus 2. Y equals -2/3 x minus 2. So there is its slope. Are any of them parallel? None of them are the same. Are any of them perpendicular? These guys? Those guys are perpendicular lines. Because they are opposite reciprocals. What's that? And isn't this right out of our last homework assignment?
Yes.
All right, so we're not going to cover that. We've already done it. And we've done the domain and range? Yes?
Yeah.
Okay, then we are done. Happy homework to you.